So this is going to be a different sort of setup. I'm just using the headset and going to be focusing on the code today. Um, I want to clean this up a little and get my functions running so that way it's sort of a modular run through and then classify all the other machine learning models, and that should pretty much fill up an hour of my time just getting that set up. As always, you can find the updated code down in the description below. And yeah, I'm gonna go get to coding. When I find something valuable that I want to talk about, I will pause the video and we can discuss it. All right, so this is cool. It was a very, very small fix. I just basically looked in my old file and saw that I actually assigned the data variable back to this np.delete, which removed the second column. So that's the only change I need to make. And then I got a deprecation warning or something. It didn't, when I'm passing in the training data or testing data, I'm not sure which one. It doesn't like that it's like a two-dimensional one row matrix. So it's just a warning. It's not anything important. So anyways, I run through this and I could tell that it ran successfully because I looked at the time that it ran in 3:21, and that's actually the time right now. So that's all I need to do. So now this is fully fit. It's really cool. So this test classifier function just goes through and runs these above functions, and I can actually, I don't know why I wouldn't even do this in the first place. So if I do this, I think it should still run correctly. Yeah, so it still does. So basically what I'm doing is just keeping all these functions inside this main function, and then what this does is it calls all these guys. So what's nice about this is everything that I need to do to train the model, to test the model and get the scores back, and actually write out to a CSV file is all done within one function using other functions too. And that's awesome. So that just helps the code be smaller. Like it's actually a couple lines more overall, um, but it's the better solution due on smaller programming projects. So I'm going to go through, apply this function to all of my classifiers, make sure that it works, and then we'll see where we're going from there. So I just ran it on the stochastic gradient descent, returning 1.0 for all of these. So I think it actually returns the probability in a different fashion, which would make this entire function not useful. And I'm pretty sure that's the case. I was skimming over the documentation yesterday and did see something that hinted that it does just that. So if we go back here, go to documentation. This isn't going to help me. I need to find. So it actually looks like it returns the same exact shape, which is interesting. So at this point, I'm going to test out what the predict probability actually works out to be. And for that, I'm going to go back to my old implementation. Actually, I'm going to not do that. I'm going to take these functions back out so that way I can use some that I know are going to work. Not have to rewrite the code and use these for all the other ones that actually will work. Which is nice. So that way I can test out, and then the ones that have certain nuances to how they return, I can adjust for those. It's fine. All right, so looking through these files, we can see that decision tree is using an either 1 or 0 in terms of predictions, which we do not want. We want a log pros probability. Um, so basically we're looking for a number between 0 and 1 instead of just either 0 or 1. It's not, we're using a regression classification problem basically. But for naive Bayes, it does do this correctly. And then for Gaussian, I think that it's simple enough that it's not working out correctly. Um, like we are getting the number that we want, but it's just not a complex enough algorithm that it's really worth going over. KNN is interesting because it only has one number after the decimal place, but it does have a mixture of numbers. So we're going to go ahead and actually try to submit this. I think it's called data learn. All right, so we're submitting the KNN classifier. And so we got 9.62. So I'm not sure. With this site, I don't know which number is better because we got like a 1 point something with the logistic regression. If I had to guess, I feel like it would be either better or worse. Does it tell me my rank? Okay. Okay, so we're using log loss. So basically what we want to do is we want to minimize the loss function as it says right here. So we want the lowest loss. So KNN was actually very inaccurate comparatively. So we want to lower our loss, and it's still funny to me how good the logistic regression algorithm was. So with that in mind, I want to try, yeah, we want to try this guy. Yeah, we're going to try the Gaussian process naive Bayes results, which obviously have more numbers. And this is log loss score of 2.5. So logistic regression actually beat out a lot of these algorithms. So with that considered, I'm actually not going to stress over, that spooked me. All right, so that leaves us with the Gaussian naive Bayes, the KNN, and the logistic regression. Um, Obviously KNN did not score that well, but now that we've narrowed it down towards these functions, we can start looking for hyperparameters to tune. And so I'm going to go back over to main.clunky, main_clunky, and start working on implementing grid search cross-validation, which will automatically do the hyperparameter testing, and we'll find the best hyperparameters for this problem. And that's what I'm going to do next. So I'm also going to get rid of the KNN just for the moment. I'm going to focus my energy more on getting these two classifiers very good and very well trained onto the data itself, and then move over to deep learning. I don't want to waste my time on sort of learning about these classifiers at the moment. I feel like there's more to learn in getting the overall picture of grid search and possibly even feature analysis too. I'm not sure how important that's going to be, um, but I definitely want to use grid search and learn more about the parameters of the classifiers that are going to be important to us and the ones I'm using right now. So what I'm doing right now is going to be using grid search cross-validation. And what grid search does is it'll go through all the hyperparameters of the actual algorithm and it will test them for me and find out which one works the best for the data given. So I'm just looking through the documentation right now and going to read through all of these different parameters that it has, and I'm going to decide which ones I want to actually test out and try. And then I'll write those down, then grid search will take care of the rest for me. All right, so for logistic regression, there weren't a whole bunch of um, parameters I could choose from. I chose C, and if we look back at documentation, C is a regularization strength. So smaller values specify stronger regularization. So I gave a little bit of different numbers here, all the way from zero point 0.1 to 2, just to test it out. And then they have different solving algorithms for this. Liblinear is the default one and is recommended for smaller data sets. Uh, but it's actually a good idea for multi-class problems, which is what we have, to use Newton CG and the LBFGS. And you can't use max iterations with the liblinear. That's why I want to choose different solvers too, because in that way I can go over here, add max iter, and then say I want 50, 100, 150, and 200 different iterations, which will only affect these two different solving algorithms, but that is useful. And so there's a good amount of diversification in the parameters that we chose and should help to give some better answers for a problem. So now I'm going to do the same for my Gaussian naive Bayes problem. So after looking at this, Gaussian naive Bayes, hello, uh, only has one parameter. I don't understand. It performs worse than logistic regression anyways. So I'm also going to get rid of Gaussian naive Bayes. And now there was one. So we're just going to focus on logistic regression. This is pretty dumb that it doesn't have any different parameters. And I'm sure, definitely want to say this, I'm absolutely sure that there's another machine learning algorithm that would do much better than logistic regression. That's what I'm just going to focus on. And I sort of want to get done with logistic regression so that way I can move over into the sphere of deep learning and get some neural nets and different neural networks and learn a lot about deep learning because I know a decent amount of machine learning already and I want to learn a lot more about deep learning. So I'm going to disregard that for now and just move over to this. Okay, so now I have cross-validation set up, and basically, what the GridSearchCV, the way to implement it is you just declare or you use the function GridSearchCV, you put in the classifier and the parameters that you want to test, and then you just fit it to this actual grid search object. And then you use the same exact functions that you would use, but it's technically the grid search object, and then you predict the probabilities via this way, and it's still the same exact output as before. So because of their submission limit, which is the dumbest thing ever, I cannot test it out until possibly 154. So I think I tested it at 1154. I definitely wasn't up at 2. Um, but I gotta wait a little before I can test this again. But once I do, I will test it. I will relay the results of what that did back to here. So I'm going to quickly add to main my changes and then probably put these in a folder called like machine learning and then start a new thing for deep learning on this problem, or possibly even switch over to a different problem because I don't like the site, how it limits my submissions, especially for a challenge that is just a warm up. It's just a test, it's just practice. But whatever. All right, so successfully just added another function to this, and I'm actually going to put everything back under the umbrella of this file. I have to indent it. And so now I have a list of all of these different functions, and they all work out and come together. So that way, all I have to do is just call this one function, pass in a classifier, the parameters, and the file name that I want, and it'll do all the rest for me. I don't have to rewrite code, which is awesome. So I'm basically done now. This file I'm going to submit later on, and we'll see what the score is of that. So I'm just going to touch up the comments here real quickly, and then edit the file structure, and then call it a day for the code. All right, so I have this folder and it has all the files that we need here. I'm going to submit this logistic regression file and see what scores I get. And then I'm going to leave this problem and never come back to it because the site limits my submissions. It doesn't give me the method that I like to use of trial and error, just keep on submitting, just keep on learning, test it out, and see what ways I can get better. Also, it's weird that they have you have to submit it in order to test how well your model actually fit. Normally, you'll be given a training set and a testing set, and you'll be able to test the testing set, as the name implies, get a score from that, and be able to iterate over that. Now, what I could do is do something like a train test split, which is a library in sklearn, a function in sklearn, which splits up the data automatically for you in like a 70/30 way or something like that. And you can use that test set as a way to see how you're doing. But there's already so limited amount of trials in here. There's not enough data to really do that effectively. So I'm not going to concern myself with that. I'm just going to call it good on this problem for the moment. I'll try and update tomorrow how I actually did when I end up submitting this. So now I'm going to look through Kaggle projects and see which ones I want to do. All right, so I think I found what I want to do for basically like this will probably last around the entire length of the project, or the challenge rather, so the whole 100 days. The first one will be using the MNIST dataset to identify which numbers are which. Just an intro to deep learning, computer vision will help me get an intro into it, learn some of the basic techniques, and give me a good starting point. And then I'm going to do this one, which is identifying a humpback whale by its tail, which is also called a fluke. And I think that will give me more practice into understanding what I need to look for and how to create a better um, computer vision algorithm. My eyes itch. And yeah, so I think that'll be good practice. And then eventually I want to go into this one, which is determining a dog breed based off pictures. So I think this one can get very complex, and there's like just a lot more stuff that I can do with this one. So basically, I will start with this digit recognizer tomorrow and just work my way through it and learn more about computer vision, which is interesting. It's not something that I've particularly like settled on for an area of deep learning that I want to do, but it's definitely a good starting off point and will give me lots of practice for the future. Anyways, that has been my hour of code for the day. Thank you for watching. Hope to see you on the vlog tomorrow for the deep learning, uh, the beginning of computer vision, or anything else, any of the other content that I'm producing. Thanks for watching.